On the morning of February 1st, 2003, a series of bright falling objects appeared over the skies of Louisiana and Texas.
There are increasing indications Columbia and its crew were doomed almost from the beginning.
As the world would soon learn, the blinding streaks of light were all that remained of the Space Shuttle Columbia, which disintegrated upon re-entry after spending more than 2 weeks in orbit.
It was just a very thin vapor line at that time.
NASA later determined a piece of the external tank's insulation broke off during liftoff, colliding with the left wing of the shuttle and fatally compromising its heat shield. It was the second catastrophic loss of a space shuttle, and all but brought NASA's shuttle program to a close.
It made me realize that the job we do as engineers is super important. No, we can't take anything for granted, even when it comes to thermal protection systems, or TPS.
Scientist and engineer Dr. Kenneth Armijo was part of the team that trained and prepared the Columbia astronauts for their fateful mission. As part of the shuttle's propulsion group, he worked in close quarters during simulations with one of the mission's astronauts.
It was important that we as engineers understood the impact that our design work did. It also showed us the importance for validation of design work. Everything looks great on paper or a chalkboard, but until you actually prove it under certain heat transfer and certain high flux conditions, you just don't know what you're really going to get.
And it's finding that certainty for space vehicles that Dr. Armijo and his team at the National Solar Thermal Test Facility are working on.
The research we do in concentrating solar thermal, with our abilities to put beams of light onto towers and onto solar furnaces and solar reactors and get to temperatures of 3,000 Celsius, not Fahrenheit, but Celsius, allow us to examine the environment's experience during re-entry for all these advanced materials and how they can survive.
There are a couple of specific projects Dr. Armijo and his team are currently working on. One, it's close to home, and the other with its sights set on a galaxy far, far away.
The first involves finding solutions for deep space probes, which will harness the gravitational pull of the sun to slingshot the vehicle beyond our solar system.
The closer you get to the sun to get the slingshot gravity effect, the faster you can go out into deep space.
However, getting close to the sun means prolonged periods of time, more than an hour, at extremely high temperatures. Armijo's team needs to ensure that the probe isn't vaporized before it even starts its mission. The second project involves using next-generation materials on orbital vehicles, materials that have come a long way since the space shuttle era. Utilizing high-temperature alloys and ceramic alloys, or CERMATs, as well as new automated controls that can detect even the slightest changes in temperatures, Armijo's team of engineers are working diligently to ensure the safety of the heat shields that can literally mean the difference between life and death.
There's a lot of need to test these materials so we can have high confidence. How can we put them through their paces so, again, we don't have any more accidents like we did with Columbia?
Sounded like a train going through our property.
With private companies like SpaceX and Virgin Galactic growing their plans for development, as well as new missions for NASA in the coming years, the work Armijo and his team are doing now at NSTTF will undoubtedly prove invaluable for future missions and future astronauts.